In the last lesson, we were looking at the effects of transformations on random variables. So we were discussing things like what happens if we add, subtract, multiply, or divide a random variable by some kind of constant. What effect does that have on the distribution, the shape of the distribution, the mean of the distribution, the standard deviation, and other measures of center and spread and position. In this lesson, what we're going to be looking at is what happens if we were to, rather than add or subtract a constant, add or subtract another random variable. So we're taking random variables, two different random variables with two different distributions perhaps, and combining them in some way. So we're going to go back to the example that we were using before with Pete and his Jeep tours. So we called the random variable X, the number of passengers on any of the randomly selected half-day trips that Pete does with his Jeep tours. And we had this information. We knew that he could hold anywhere from 2 to 6 passengers, and we had the probability of any number of passengers given to us as well. So we had looked at the distribution. We had discussed the mean of that distribution and the standard deviation of that distribution. Now let's say that Pete's sister, Erin, who lives in a nearby tourist area in another part of the country, is impressed by the success of Pete's business. So she decides that she's going to join the business, running tours on the same day as Pete in a slightly smaller vehicle under the name Erin's Adventures. After a year of steady bookings, Erin discovers that the number of passengers Y on her half-day tour has the following probability distribution. So the figures below are giving the distribution information and the histogram, and we're defining the random variable Y to be the number of passengers now that Erin has on her half-day tours. So if we look at the table, we can see that Erin's tours can take anywhere from 2 to 5 because she can carry slightly less passengers. We have the probability for each number of passengers. We have the distribution and a histogram, and we also have the mean and standard deviation. And by the way, this is a typo because we're looking at the mean for Erin and the standard deviation for Erin. That should be mu of Y, since we defined Y to be the number of passengers that Erin can carry, and the standard deviation sigma of Y. So the probability of Erin having 2 passengers is 0.3. Of 3 passengers is 0.4, for 4 passengers is 0.2, and for 5 passengers is 0.1. For any 2 random variables, X and Y, if T is the sum of those 2 random variables, in other words, we're taking the outcomes for X, the outcomes for Y, we're adding them together, then the expected value of that sum, T, or the mean of T, will just simply be equal to the mean of the first random variable plus the mean of the second random variable. In other words, the mean of the sums of the random variables is the sums of each of their means. And this extends to more than just 2 random variables. So in general, the sum of several random variables, the mean of the sum of several random variables, will just be the sum of their means. So if we were adding 3 random variables, we would add all 3 of the means. If we were adding 4 random variables, we would add all 4 of the means, and so on. So we want to know how many total passengers, T, will Erin and Pete have on their tours on a randomly selected day. So in other words, we're going to create a new random variable, T, and it's the total passengers that Pete and Erin have. So the total passengers that Pete has is X, the total passengers that Erin has is Y, so the total passengers for both of them combined will just simply be X plus Y. And so if we want to know what the typical expected number of total passengers T would be on any randomly selected day, we're looking for the expected value of T, or mu of T, which would just be the mean for Pete, so mu of X, plus the mean for Erin, mu of Y. We know that Pete's expected number of passengers is 3.75. And they gave us that mu of Y, the expected number of passengers for Erin, is 3.10. So the expected total number of passengers for both of them would be 3.75 plus 3.10, or 6.85 passengers. So that gives us our expected value, or our mean. But we also might want to look at things like variability. So the next example asks us, how much variability is there in the total number of passengers who go on Pete and Aaron's tours on a randomly selected day? And we know that there are several ways that we can measure variability. One of the simpler ways that we can look at variability is to discuss things like range. And in this case, to find the range of the total number of passengers, we would have to take the maximum number of passengers that they could have total and subtract the minimum number of passengers that they could have total. In other words, we would need to know what is the minimum number of passengers that they could have total. We'll call it minimum of T. And what is the maximum number of passengers that they could have total? We'll call it max of T. So if we go back to the distributions, we know that the minimum number of passengers that Pete would carry is 2. And they've also given us that the minimum number of passengers that Aaron will carry is 2. So the minimum that they could have total would be Pete's smallest amount, 2, plus Aaron's smallest amount, 2. The minimum that they would carry on any particular day then would be 4. Now for the maximum, we know that the most passengers that Pete can carry is 6. And then they also gave us that the most passengers that Aaron can carry is 5. So if they both were at maximum capacity, then the maximum total that they could carry would be Pete's max, 6, plus Aaron's max, 5. So the maximum that they could have on any given day would be 11. Which means that the range for T, we'll call it range of T here, will be its maximum, 11, minus its minimum, 4. So the range would be 7 passengers. Now I want you guys to notice something. If we go back to the distributions here, and we look just at Pete, notice that Pete could carry anywhere from 2 to 6 passengers. So the range for Pete, range for X, would be 6 minus 2, or 4. If we look at Aaron, she can carry anywhere from 2 to 5 passengers. So the range for Aaron, we'll call it range of Y, would be 5 minus 2, or 3. So if we look at the variability in form of range for Pete and the variability in form of range for Aaron, we have 4 and 3. Notice that what we ended up with for the range, the total range for both of them was 7. That's not a coincidence. It turns out that when we are combining random variables, again, T is the sum of those two random variables, X plus Y, the range of that sum, the range of T, will be equal to the range of X plus the range of Y. So again, when we're adding them together, we can just simply add together the ranges of each of the random variables, and that will become the range of our combined random variable, the sum of both. So before, when we were looking at probability, we talked about this idea of independence. And when we were talking about independence as far as outcomes in a probability distribution, we said that 2 events were independent if knowing the outcome of one had no bearing or no effect on the outcome of the other. So each trial or each experiment or each outcome doesn't affect any subsequent outcome. And that's what we said independence was. We can apply this idea to random variables too. If knowing whether any event involving X alone has occurred tells us nothing about the occurrence of any event involving y alone, or vice versa, then we say that x and y are independent random variables. So again, the same idea of independence kind of carries over here. So let t equal x plus y just like before. X and y would be independent variables because we're talking about tours in separate parts of the country. The number of passengers that we have in one area for one tour would have no effect on the number of passengers in another area. So x and y are both going to be independent random variables. We could come up with the probability for each of the possible combinations or values of t. We know that the minimum is 4 and the maximum is 11, so we could look at the probability for each of those individual outcomes. So for example, the probability that t equals 4, that the total for both of them would be 4 passengers. Well, there's only one way that that could occur. The only way we could have exactly 4 passengers total is if both Aaron and Pete have their minimum number of passengers for that day. So the only way we could have a value of 4 for our total t would be if both x and y were equal to 2. So the probability of t equaling 4 is the probability that both x and y are equal to 2. And using our probability rules before for the intersection of events, since these are independent, the probability of event A and event B happening is just simply the probability of event A times the probability of event B. So the probability of x being 2 times the probability of y being 2. And from our probability distributions on the previous page, we know the probability of Pete having exactly 2 passengers is 0.15. The probability of Aaron having exactly 2 passengers is 0.3. So the probability of x being 2 is 0.15 times the probability of y being 2 is 0.3, gives us a probability of 0.045. In other words, the probability of them having exactly 4 passengers would be 0.045. We could extend this for each one. So there are actually 2 ways that we could get a total of 5 passengers. We could either have that Pete has 2 passengers and Aaron has 3 passengers, or we could have that Pete has 3 passengers and Aaron has 2 passengers. And again, these are independent events. The probability that Pete would have 2 passengers, we said before, is 0.15. The probability that Aaron would have 3 passengers from our probability distribution for y is 0.4. And again, because these events are independent, the probability of both of those events occurring is just going to be the product of the 2. So 0.15 times 0.4. Likewise, the probability of x being 3 and y being 2 is, again, these are independent, so it's just going to be the product of each of those outcomes. The probability of Pete having 3 passengers is 0.25. The probability of Aaron having 2 passengers is 0.3, so we multiply those together to get the product. Then we're combining those as a union. So we're saying that we could either have x be 2 and y be 3, or we could have x be 3 and y be 2. So now we're looking at that addition rule, and these are disjoint events because we either have this or this outcome, but we couldn't possibly have both. So we're just using our addition rule for disjoint events here. And to combine those, the probability of this or this would just be the sum of both. So the probability of x being 2 and y being 3 is 0.06. The probability of x being 3 and y being 2 is 0.075. The probability of outcome 1 or outcome 2 is the sum of those, which gives us a probability of 0.315. Now, if we were to continue this, it would start to get a little bit complicated because when we got to 6 passengers, there's going to be even more ways that we could have that happen. We could have that Pete has 2 and Aaron has 4. We could have that Aaron has 2, and that Pete has 4. We could have that they both have 3. So there's lots more combinations as we continue this pattern on, but we would follow those same rules using our multiplication rule for independent events and our addition rule for disjoint events, because each of those would be independent and disjoint. And we could continue to calculate the probability for each one of those outcomes. So for the sake of time, I went ahead and gave you that information. This is our probability distribution for each of the possible values of t. and their corresponding probabilities. So we had already calculated 4 and 5. If we continued that pattern, we would have the rest of those probabilities. And by the way, there is a typo right here. That should be 0.005. I did leave the decimal off there. And so with that, we can calculate the mean, the variance, and the standard deviation of t. We're going to do that with our calculators. So just to review, whenever we have a probability distribution for a random variable to calculate the mean and standard deviation, we're going to create two lists, one list with our values and one list with the corresponding probability for each of those values. So we'll go to our list and edit. I'm going to do list 1 and list 2. List 1, my possible values are 4, 5, 6, 7, 8, 9, 10, and 11. And in list 2, I'm going to put the corresponding probability for each of those values. So for 4, the probability is 0.045. For 5, the probability is 0.135. Then we have 0.235, 0.265, 0.19, 0.095, 0.03, 0.005. Just double check those real quick. Okay. So now once we have all of those values entered into our lists, to calculate the mean, the variance, and the standard deviation, we go back to our stat menu, we go to calculate, and we select one variable stats. Our list is the list containing our values, so that was list 1. Our frequency list is the list that contains the probability for each of those values, so that was list 2. And now if we go to calculate, we get that the mean, mu of t, is 6.85, which is what we calculated earlier, so that just kind of verifies what we saw. We have that the standard deviation, sigma of x, is 1.4414, if we round that. And if we scroll down, does it give us... Oh, it doesn't give us the variance. But remember, we can calculate the variance by simply squaring the standard deviation. So the variance, sigma of x squared, is going to be our standard deviation squared. So we take 1.4414 and square that. And we get that our variance is 2.0776. So our mean, our standard deviation, and our variance. So if we look at the variance for x and the variance for y, the variance for x would be that 1.0897 squared, so 1.1875. And the variance for y would be that 0.943 squared, so about 0.89 roughly. We can see that if we just add the variance, we'll end up with the variance of the total. Notice that adding the standard deviations doesn't give us the same result. If we take the standard deviation for x, 1.0897, and we add the standard deviation for y, 0.943, we end up with 2.0327, which is not the same as the standard deviation. Oh, I just realized that I wrote this wrong. For the total of these should be t's. So this is the standard deviation of t, the variance of t. So we can calculate the sum of the variances, or we can calculate the variance of the sums by finding the sum of the variances. But we can't calculate the standard deviation in the same way. In other words, if we want to discuss variation by using the standard deviation, first what we're going to have to do is we're going to have to calculate the variance, sigma squared, which will be the sum of the variances for each of the random variables. And then once we have that, we can just take the square root to get back to the standard deviation. So for any two independent random variables, x and y, if t is the sum of x and y, then the variance of t, the variance of the sums of the random variables, is the sum of the variance of each of those random variables. And just like with mean, we can extend this beyond just two random variables. So if we had three random variables and we wanted to calculate the variance, then we would add the variance of each of the three random variables. And then if we needed the standard deviation, from there we could just take the square root. So in general, the variance of the sum of several independent random variables is the sum of the variances of each one. In our next example, it says that Pete charges $150 per passenger. Aaron charges $175 per passenger. We want to calculate the mean and the standard deviation of the total amount that Pete and Aaron collect on a randomly chosen day. So what we need to do is we need to define two new random variables. I'm going to let C equal the total amount that just Pete charges, or Pete collects. Pete is going to charge $150 per passenger. So if I want the total amount that Pete collects, I'm going to have to take the number of passengers that Pete has on any trip, which is X, and multiply it times $150 per passenger. So C would be $150 times the total number of passengers that Pete carries. And that would give us the amount that Pete collects. Likewise, I'm going to define another random variable. We'll call it D. And I'm going to let D be the amount that Aaron collects. Tell us that Aaron charges $175 per passenger. So to find the amount that Aaron collects, we'd have to take $175 and multiply it times the number of passengers that she's carrying, which we've defined to be Y. And then once I have that amount, the amount that Pete collects and the amount that Aaron is collecting, to find the total amount that Pete and Aaron collect on a randomly chosen day, I would just add each of those. So I'm going to define one more random variable. We'll say W. And we'll call that the amount that Pete collects, C, plus the amount that Aaron collects, D. In other words, this is the amount they collect together. So what I'd like to do is I'd like to stop there and let you guys try this problem. So if you go back to your notes, we discussed how you can calculate the mean and the standard deviation when we take a random variable and multiply it by a constant. So if you need to, you can look back in your notes and review how to find that. Then once you have the mean and the standard deviation for C and D, you can use the rules that we've added today to calculate the mean and the standard deviation of W. Remember that to find the mean of the sum, you're going to add the sums, to find the mean of the sum, you're going to add together the means of each individual outcome. To find the standard deviation of the sum, first you'll find the variance by adding the variance of each of the outcomes, and then you can just take the square root of that to find the standard deviation. So take a few minutes to see if you can calculate those values, and then when you're ready, come back for the next video.